Hey everybody, it's Mr. Carr again. Today we're working on 1.2 day 2, graphing equations of lines. So again, this is going to be a review of something you've done in the past. So let's take a look at some of our key points here. So start with slope-intercept form. Slope-intercept form gets its name because it tells us the m, which is the slope, and the b, which is the y-intercept. So my first example here, y equals 2x minus 1, we know that the negative 1, I'm going to start by plotting 0, negative 1 as a point. So that's going to go right here. From there, my 2 is my slope. Now remember, slope is rise over run. So I can treat it like it's a 2 over 1, which is a positive 2 over a positive 1. So that means I can go up 2, that's a positive direction, and I'm going to go to the right 1. So I go right here. I can do that again if I want. So up 2 to the right 1, and whatever number of times I want to do, it's up to you. From there, we can also go another direction. Since it's an overall positive slope, that's the same as a negative 2 over a negative 1, because a negative divided by negative is positive. So I can instead go down 2, which is negative, left 1, which is negative. And then same thing again, down 2, left 1. Okay. So draw my nice straight line there, and there's my 2x minus 1. Here's another example. Let's do this one in blue. Now, this one is not in slope-intercept form, but we can transform it. We can make it look like that. So keep in mind, we have y by itself with no variable or no number in front except for 1. So I'm going to start by adding 4x to both sides. A little bit more space here. So negative 5y is equal to 4x plus 10. And then I can divide every single term here by negative 5. So when I do that, I get y is equal to a negative 4/5 x minus 2. Just like the previous problem, we're going to identify the y-intercept to start, which is 0, negative 2. So I'll plot this point right here. My rise over run is a negative 4/5 overall, which means I can treat that like it's a negative 4 over 5 or 4 over negative 5. So what do I mean by that? Negative 4 in my rise tells me I'm going to go down 4, and then I'm going to go to the right 5 or a positive 5. Whereas positive 4 means I'm going to go up, but then I'm going to go to the left to make it a negative 5. So if I do that, I got 1, 2, 3, 4 up, 1, 2, 3, 4, 5 to the left, or 1, 2, 3, 4 down, 1, 2, 3, 4, 5 to the right. So this is one, whoops, fix that. There we go. So that's one option of graphing that. We transform it into y equals mx plus b first. This equation was in a bit of a standard form, which is of this format, ax plus by equals c. So we have typically a, b, and c are integers, and most times you'll have the a be a positive value, but it doesn't always have to be. There's a different way to graphing those if we wanted to. Sorry about that. Just want to make sure there's no music on the video on that one. So what we have for our graph, in order to graph this, is we could transform it if we wanted to. We would subtract 5x over, divide everything by 2. The other option is I can make a XY chart and look for my X and Y intercepts. Okay, so a Y-intercept, remember, is always X equals 0 and Y equals some number. An X-intercept is going to happen a similar way. You're going to have a number in the X direction and 0 in the Y. So what I can do is I can plug those in real quick and solve for the other value. So for example, 5 times 0 plus 2y equals 10. That actually is just going to go away. So we get 2y equal to 10. So if I divide by 2, y comes out as 5. So 0 is x, y is 5. If I do the same thing here with 2 times 0, and I solve for x then, same exact thing is going to happen. There we go. This is going to go away. So I get 5x equals 10. So let's divide by 5, and I get x equals 2. So I can plot 2 points, because that's all I need for a graph. I need 2 points to graph it. So 2, 5, or sorry, 2, 0, and then 0, 1, 2, 3, 4, 5. This is going to be the same thing if we first transformed it. Okay. We can also do some horizontal and vertical lines. Horizontal lines are always y equals a number, vertical is x equals a number. One of the ways I like to look at this, so if I do, for example, x equals negative 3, if I plot a series of points where I make sure that negative 3, so I go 1, 2, 3 right here, and let's do like all these points here, something like this. So if I label those points, what I have is this should be -3, 8, -3, 1, 2, 3, 4, -3, 2, -3, 0, -3, 1, 2, -3, and -3, -4. The one thing that's consistent is that x is always -3. Well, if I keep making those dots on that line like that, that's how I get to a vertical line. So my vertical lines are x equals a number. So it looks like that. So x equals a -3. Y equals 2 is going to work the same way. Let me do that in blue here. If I start plotting a bunch of points like this, do this one too, and this one like that. So this is the point -3, 2. Here's 0, 2. Here's 2, 2. Here's 2, 3, 4, 5, 2. What's consistent is that y is always 2. So if y equals 2, that's what creates a horizontal line. Any point that's on that line is of the form y equals 2. Okay, so in a real life situation for modeling word problems, the slope represents a rate of change, like we talked about in the previous lesson. And the y-intercept can be called an initial value because we don't really care about like negative x values. So starting at 0 is our initial value. So our m is rate of change, b is initial. So we're going to use that to help with this type of problem. The body length y in inches of a walrus calf can be modeled by y equals 2 or 5x plus 42, where x is the calf's age in months. Explain what the 5 and 42 represent in this problem. I'm going to start with the 42. So 42 is the initial body length, which means it's going to be 42 inches. Okay, that's what our initial idea is. 5 is the rate of change. So because our time, we're changing inches in comparison to months, that means it's changing 5 inches per month is the idea. So now what we can do is we can use that to graph, and you're going to do this. If you do this in TI-84, here's your steps real quick. You're going to do TI-84, click on Y equals button, and then you're just going to type in. It looks like this in a window. It'll be like Y1 or Y2 or anything like that. So Y1 equals, and then you're going to do 5 times the X button. Okay, look for that button there, plus 42. You go to the graph, you go to change your zoom a little bit. I'm going to go ahead and do the same thing, but I'm going to do it in Desmos. So we can pull it up right here. So I got a little extra here, but don't worry about that for now. So Y equals 5x plus 42. So you can see some of the window here. You can see where it's crossing for that initial value of 42 inches. And it's changing up by 5 per month is the idea. Okay, so use the equation to predict the body length of a 10-month-old calf. So a 10-month-old calf means that x is equal to 10. So y is going to equal to 5 times 10 plus 42. Y is equal to 50 plus 42. So y is going to equal to 92 inches in this case. Okay, and that is it for today. So again, we're talking about our linear equations. We're talking about graphing them using our slope and y-intercept, maybe plotting some points if we're going to find some easy points like our x and y-intercepts, things like that. Then also modeling our problems using the idea of y-intercept is our initial value and our rate of change is our slope. Okay, that's it for today. Take care, everyone.